So should I share the slides on here? Should I be sharing the slides via Google Meet? I mean, I don't know. Yeah, how's the best way of doing it? Is it just me to share screen? Okay. Um, yeah. Quite spot. Just let me know when I should start. So just let me know when I should start. Okay, cool. Wait, so am I like on a screen or something? It's like, or is it? Okay, cool. Hi everyone. I'm going to be talking about combining scalability with interoperability and avoiding fragmentation for Ethereum layer 2, especially in DeFi. So DeversiFi is an existing layer 2 scaling solution for DeFi. It's been live for about a year, and we work with Starkweb. And we have a kind of a unique solution to this, but I'm going to be talking more generally about how it can apply to lots of other layer 2 solutions. So just a bit more about DeversiFi. Specifically, what we've built is a very application-specific solution for DeFi. So making it really easy to swap and yield, do the kind of 99% of what most people want to do in DeFi without paying gas fees, without failed transactions, because it's all on a layer 2 solution. And today, if you go to DeversiFi, you basically onboard, connect your MetaMask, Ledger, or other wallet, and can do all of that. But the big difference being that you don't need to, if you want to earn yield on Compound, for example, you don't need to go and make a deposit and pay gas fees for that. You can do it all within this interface, and you don't pay any gas fee. And the sort of big way that we achieve that is by using a layer 2 solution, and specifically we're using Starkweb. So it's built in Cairo, which is a language for writing and building in the Starkweb ecosystem. And so we get all of the security that you get from Ethereum with much higher transaction throughput, much lower cost, and full self-custody around all the assets that are held and managed in DeversiFi. And so on the kind of, from that perspective, there's a lot of benefits, but also completely fast and frictionless. All transactions are real time. You don't need to wait for them to be included on chain. And that's achieved by using zero knowledge proofs for for all transactions. So essentially, a certain number of transactions are collected. They're all proved to be valid in the sense that that anyone who's making, for example, a transfer has the correct balance and has signed that they want to send it to someone, and those all get included at the end of a batching period into one proof, which is what's submitted on chain and verified by a contract that ensures that everything was correct. So in terms of how this particular scaling solution works, it's application specific, so it's not EVM based. You can't just deploy any Solidity smart contract. It's very much tailored for, in our case, trading and making transfers. Those are the two operations which the entire solution is built around, and means that for those operations, it's very, very efficient. So in production today on mainnet, on average, a proof contains 4,096 transactions, and a proof that we would submit to be verified on chain of that size uses around 4.5 million gas. But the interesting thing about this and why it's such a great scaling solution is that actually, even if we were increasing those proof sizes and including more transactions as layer 2 gets more adoption, the gas wouldn't increase linearly, it scales sublinearly. So that cost of a batch is roughly fixed, but today it's already using less than 1,100 gas per trade or transfer, which of course is much, much cheaper than using Uniswap or other layer 1 exchanges or DeFi applications on Ethereum. But the sort of issue that's now appearing is that there are many different layer 2 apps and layer 2 scaling solutions appearing on Ethereum. It's very much the ecosystem is very organic, and that's part of the appeal of Ethereum. It's fully open, anyone can build anything. And so we've had teams all over the world implementing different solutions without any central planning. And so today we have very many, or an increasing number of single application scaling solutions using layer 2. So for example, DeversiFi, but also Loopring, Hermes, and ZK Sync for transfers, which are all live on mainnet and can handle many thousands of transactions and with very low cost. But these all are all implemented in different ways. And so, and even in the kind of next wave, we're seeing that there's many generalized scaling solutions, including Optimism, Arbitrum, and in the future, Starknet, which are in beta or close to launch, where you can deploy, for example, Solidity smart contracts or contracts written in Starkware's Cairo language. And that's leading already, even though layer 2 is only just getting some adoption, to a fragmentation, because all of these different solutions have usually only the ability to deposit and withdraw from them, to onboard and offboard from Ethereum layer 1, which has, again, like a cost to do. But in the future, as we see increasing adoption of these solutions, that's going to mean that people need to at some point have their funds on layer 1 in order to onboard. And if gas prices keep rising, and if more and more sort of end user applications end up being on layer 2, that becomes an issue. But also liquidity, for example, if we have Uniswap on Optimism or already existing markets on DeversiFi, is much harder to arbitrage and keep in sync across all of these different solutions than it is today on layer 1, where we have the ability to have fully composable transactions. When someone makes a trade, there are many different components that interact together, and that's something that doesn't work today on the layer 2 ecosystem that's evolving. So one of the kind of most obvious issues here is that withdrawals from Optimism or DeversiFi or Loopring take some time, and there's different reasons for that, but it can be 24 hours or longer. In the case of a zero knowledge rollup, it's because of the time taken to actually generate the zero knowledge proof that's then submitted on chain and verified. In the case of optimistic rollup, it's usually because there has to be a delay period before the state can be finalized on layer 1. And that, of course, leads to serious UX issues, but also means that it's very difficult to then move directly between different layer 2s. And I think ultimately what we're seeing is that the likely future way that most people will use Ethereum will be to use layer 2s, but layer 1 will provide a backbone of liquidity. So there may be protocols like Uniswap and Aave, which provide deep liquidity, and ultimately layer 2 needs to be able to interoperate with to access liquidity. And so we need a solution to this problem. Many people are working on some potential solutions. Trusted bridges, which include moving funds between centralized exchanges, are already something that exists. And we're seeing, for example, Binance being like a clear example of that, where people move to Binance Smart Chain or Polygon. But there's another wave now of trustless bridges being built. We're seeing wrapped assets from other blockchains, and also the concept of mass migrations, where we could essentially build a standard to let people move their funds between different layer 2 solutions instantly at much lower cost than having to individually each withdraw to layer 1 and then redeposit. But the solution that we're using at DeversiFi, and which I think is a standard that will be increasingly implemented in many other at least zero knowledge-based roll-up scaling solutions is the concept of conditional transfers. So a conditional transfer is a fundamental tool which exists in the case of DeversiFi, where if you essentially under a normal transfer, a user signs the amount they want to send to a particular address and then submit that, and that will get included into a future proof. With a conditional transfer, you're essentially saying that I will transfer to someone else, but only if a certain condition is met. And that condition can be anything that can be verified on layer one. So the clear example that we're using it for today is to have fast, close to instant withdrawals from layer two back to layer one. And in this example, Alice has a layer two account on DeversiFi and has 1 ETH there. She signs a conditional transfer to the operator and says, I will give you my 1 ETH, but only if I receive 1 ETH on Ethereum. And actually, the exact thing that she signs includes a contract specified on layer one, so a normal Solidity smart contract that will register the kind of a fact which verifies that the transfer occurred to her on layer one. So after she sent this signature to the operator knows that as long as they send the required amount on Ethereum, they will be able to claim it on layer two. And so it makes the transfer via this transfer registry contract to prove that it occurred, which means that at some point later, let's say 30 minutes later, when the next proof is submitted on chain, containing all of the transactions that occurred in DeversiFi, that conditional transfer will be considered valid by the proof, and valid in the verification of the proof, and therefore will have occurred. So this is a really, really flexible and powerful concept. And of course, in this sort of example of fast withdrawals, that's solving an immediate need today. But looking slightly further down the line, we can also think of this being used to do direct movement of funds between multiple different layer two solutions without needing to wait for proofs to be submitted or for a batch waiting periods to end. So you could, for example, use this today in the current way it's implemented, and to directly send funds between DeversiFi and DYDX, which are both built on using Starkware and contain this conditional transfer mechanism. But in the future, you could also make the condition based on an oracle or actually anything that can be seen on layer one. So, for example, if you wanted to build a different order type that was only valid under certain conditions, certain market conditions, for example, like a stop limit order where you want to sell a certain amount of Ethereum, but only if a price goes below a certain point. You can do that using this, because the condition that you would use would be a layer one oracle, which basically just says whether the price is above or below that threshold. So this is something which is incredibly flexible and really sort of empowers builders to create whatever they want. And the way that it's actually currently implemented means that independent teams can actually deploy new transfer registry contracts on Ethereum, and would be able to then register them. So if someone wanted to create an arbitrage contract between layer two and Uniswap or SushiSwap, they can do that, and the actual like Solidity implementation would say would register a fact only if there was a successful trade on SushiSwap, and this means that you can then create basically liquidity sharing between layer 1 and layer 2, and not get this kind of fragmentation of everything that goes on layer 2 being slightly out of sync with the rest of the market. And so sort of looking ahead, I think the way that we're starting to see layer 2 emerge would be that ultimately all end users would be interacting with DeFi via layer 2 and won't be paying gas to do so. But all let's say trading, for example, and swapping would internally match on layer 2. But if it needs to access deeper liquidity or more liquidity than is available, would lead to using a mechanism like this to access that to fill any remaining quantity of orders. And this mechanism is one of the ones which will really allow that to happen. So thank you very much for listening. DeversiFi is hiring at the moment. We've got a few different roles open, including in particular data analyst, blockchain researcher, and a lead full stack developer in JavaScript. So please speak to me if you're interested. And we're really happy backed by a great set of companies in the space. Thank you very much. Yeah. I mean, so for example, I think you're talking about this slide. I put Hermes and ZK Sync on the left side because today what's live is kind of their version ones, which are basically just doing transfers. And so very, very efficient transfers, particularly tailored for that. But I think in both those two cases, they are building EVM solutions that will allow more arbitrary logic to be, any smart contract to be deployed, and they would sit on the right side. In the case of Starkware in particular, so whilst what we're using, I mean, is essentially implemented in Cairo, you could build, in theory, any application, optimized for other things. So Starknet will be coming in the future, which and already there's a beta which is available to test that does allow anyone to build anything and deploy it, and so DeversiFi will be migrating to that when it launches, which is going to be almost an open, composable, permissionless system. But rather than writing in Solidity, you write in Cairo, which means that you're sort of more closely. It's a language that's more tailored to the way that zero knowledge proofs work, and more optimized for that. Yeah. No, so actually, the thing about that is, so this conditional transfer, the way that it's actually implemented, means that what you sign is just a hash, and the hash is generated in a certain way that it basically includes an Ethereum address, which is a smart contract. So it's very flexible from that perspective that the proof system doesn't need to know what that contract is. It doesn't need to know what logic was implemented on layer one in that contract. It just needs to be pointed at that address and then look for a specific type of fact that was registered. So if you're writing this layer one Solidity smart contract, you make a function. You have to ensure that it will basically register a fact. It's just saving an information that can be checked by the proof. But other than that, the actual prover system doesn't need to know what it does. So in the case of the fast withdrawals, when you call this function, all it does is save this fact that the transfer happened and then make the transfer. But if you were making an arbitrage contract, you would again save the same fact and make a trade on Uniswap. So that's why that's possible today without needing to write specific logic for it in the actual layer 2 implementation. Great, thank you very much.